Hi, it's mail time. I have received two new boxes today, and one is from Seed Studios in China. I ordered some stuff and it's in the mail. And the other thing is this. This is a FedEx package with the sender as, I can't even pronounce the name. It's from somebody in Linwood in the US. Now, this is from Cyprus. I know what is inside. I enrolled for a design contest with Hackster.io, and my idea won one of the 100 kits that were available up for grabs by the Cyprus, and well, this is one of them. So I'm going to unbox this as well as the stuff that I bought from Seed Studios in China. So let's see what's in each box. As you can see, this box has been opened already by customs. It's a small box. It's been opened by customs, and they do this in India to check sometimes what's in the box. Mind it that I'm telling you right now that Indian customs will check FedEx boxes even if they have a value of $50 or $100. If you've already specified it's something less, they probably won't read it. And if you have some value of $2,000, they're definitely going to open this up, and they're going to go through the documentation and stuff. They're very meticulous about that. If you send anything via registered post or your China post or Singapore mail in this case, or even the Royal Mail from the UK, I get a lot of stuff from friends abroad, and whenever they send this stuff, it always passes under the radar. The declared value for this thing is, I think, $14. So $14, $15, $100 worth of anything via registered post is going to just fly under the radar. And I'm not saying you should cheat, but then they don't check. And the worst experience I've had is with a microcontroller, a single chip, which was a sample from Cyprus. Its value was about 25 cents, and they charged me about $50 worth of custom duty on that, and it was just ridiculous. It was impossible to argue with them, but I ended up paying $50 for a 25-cent microcontroller here in India. All right, so this is the PSOC analog coprocessor Pioneer kit. All right, so you can see that the seal has already been opened thanks to customs. Taking a look inside, there we go. All right, so it has a getting started guide. There is, I don't know what this is. It's, I think, sensing for something. And this is the board. All right, there we go. So you can see that it has a couple of things on it. So this is definitely going to be the Fresnel lens cover for an underlying PIR sensor. Let me just take it out. Yes, you can take it out. It's been glued there, but it's not going to be very successful in my... There we go. So it's been more or less ruined. Thank you very much, Cyprus Manufacturing. But hold on. Can you see this? I'll take a picture and upload it. All right. So there is a PIR sensor under there, which is going to monitor, which is going to generate a voltage depending upon the heat signature it detects. So you can use a differential amplifier or a differentiator to find out if there is a modification or a change in the voltage levels, and then you can generate a signal. Then there is a thermistor, a very crude way to measure resistance, but there it is. This black little dot in the middle, that is the I think that should be the humidity sensor. I don't know how that works. And this bottom pad right here, that's going to be the touch sensor. So that's the capacitive touch sensor, and Cyprus really takes a lot of pride in its CapSense technology. I have a couple of CapSense boards and they're really good. So you can see that it is of the Arduino form factor. All right, so it can be used with an Arduino. There is there's an unmounted footprint for a CR2032, which I'm not going to mount. Let me see if it's in the kit. And it comes with some headers, and I don't know why they didn't actually mount the headers, because you can see that there are two headers in parallel. One of the headers has been mounted, and that's supposed to go on top of a baseboard, which is probably going to be an Arduino. And these are the headers that you can mount. I don't know why they didn't go with the stackable header, but they seem to have done this particular structure for this board. I don't know what this connector does. I think it's an additional header connector, and this is probably going to be the USB connector for accessing the programmer, because these PSOCs normally have a part of the board which is the programming board, programmer part, and it's going to be somewhere. So there's a reset switch and a couple of things. This is the first time I'm taking a look at this, so I have no idea. Yeah, so there is a switch over here which allows me to shift between the regulator output. There you go, hold on a second. You can see this regulator output. The middle one is the USB, and the third one is the battery. So you can shift between what voltage, what power supply you want to use for this. There's a power domain monitor switch which allows me to do a digital or analog. So there's a couple of sensor switches. Basically, this is the mother of sensing. So they have put everything they could to sense. So they supply this antenna kind of thing. This is actually just a jumper, so you can use it as a touch button. I don't know. Just plug it in and then touch. I'm gonna try and experiment with that. So probably this is gonna come into a 3D printed enclosure with the pad exposed and this part exposed, the rest of it covered, something like that. I'm gonna make something out of this. So I'll post an update of this thing when I do some stuff with it. I really don't know what this is. I don't know. They have some kind of I don't know, capacitive thingamajig. I don't know. So that's about it for the PSOC. This is for $50, available on Element 14. If you want to buy this one, go right ahead. Element 14 didn't send me this. This was sent directly by Cypress. So I love Element 14, but they didn't send me this one. They've sent me a lot of other stuff though. Second box. This is from China, Seed Studios. Another one of my favorite vendors. I bought this stuff. None of this is free of cost. They had a Halloween sale, and I was half asleep, and I decided, you know what? Let's go shopping online. And yes, stringable RGB LEDs. I have a bunch of these, and I used the same LEDs in a project. If you want, I'm going to post a link if you want to visit that project. That was the Internet of Holiday Lights, and I got, that was a good project, if I do say so myself. It was connected to the internet. It was a Christmas tree with 120 of these strung on a Christmas tree, and I did a couple of permutations and combinations on how to do it. Ooh, nice. This is a push button. So this is one of those anti-vandal switches, illuminated ones. I think this is an illuminated switch, so you can give 3 volts to it and it'll glow in a green circle. I really love this one. See, you can buy these off of Seed, but I don't know, I'll check out how. Tick 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 tick. Nice, very nice. Oh yes, I could have ordered a sample for this, but I just wanted to buy one of these. This is the STM32F030 Nucleo. It's the M0 version of the STM32. I wanted to actually do a project, low cost module for somebody. So instead of actually getting a sample, requesting a sample and then going through that, it was cheap. So I bought that. Oh, nice. And these are for another project that I had in mind. Arcade buttons. That's right. So this is with, I've got how many of these? I don't remember. It's 2 greens and 2 yellows. These are going to be connected to a Raspberry Pi, and probably I'm gonna have to buy a joystick. I didn't buy a joystick from Seed. They were expensive. So yep. Clicking sound. Another anti-vandal switch from Seed. Let me open this up. And this one is in gold. Can you see this? Now this is just a momentary press button. I have a project in mind for this as well. What are these? Oh, these are the same LEDs that are being used in this, and these are the NeoPixel LEDs. But I got, I think, 20 of these. 10 packs of 10. Yeah, packs of 10. So they send me in these kind of packs. So these are WS2812S. So these are serial RGB LEDs, and I have a PCB I already have made, and these are again 2 more buttons, 2 more switches. So yep, so that's about it. So I've got some buttons, a lot of these anti-vandal buttons, and these buttons, and some RGB LEDs and stringable LEDs. This is something that's going to be useful because they have this part of the PCB. Let me just open it up. They have a, oh, how do you take it out? Come on, come on. So we have this board. So you can see that it's more or less has a groove cut out on the PCB itself. So you can clip this part. I can just, clip it. And this can work as the programmer on its own. Yes, it's cheaper to buy a programmer, but it's the system itself. This is a lot more cheaper when you're experimenting with microcontrollers, and especially with the ARM microcontroller. There's a very nice tutorial by a friend of mine at electronut.in. I'm going to put the link down here. So from electronut.in you can see the tutorial. It's about the ARM controller, ARM GCC, which you can use to program this microcontroller. In addition to this, you have the option of embed. So what I'm looking to do is I'm going to probably experiment with this, and I'm going to crack it open. And I'm not interested in using embed. I'm going to use the ARM GCC to actually program this bad boy, and I'm going to develop a custom firmware that I can use somewhere else. So it was intentional for me to get an ARM Cortex M0 because in applications that use a simpler microcontroller where you have a lot more requirement of memory, this is actually quite economical. In bulk, it costs quite less. So that's about it for this edition, and I'll see you when I make a project or if I come up with another mailbag section. If you like this video and the work that I'm doing, please support me, subscribe and like, and if there's something specific you want me to do or deal with, or if there's some tutorial that you want me to do, just leave a comment below and I will be happy to oblige. Thanks.